evening, everyone. Well, I suppose you're probably watching this at night, so good evening. This is going to be the answers to the review sheet that you guys received in class, review for your test on Chapter 4, which is functions and inverses. So we will proceed going through the problems. If at any point you don't have a question on a problem, feel free to just skip forward and fast forward and go to the problems you need. So here in part 1, we're going to find the equation, the domain, range, zeros, and discontinuities, and of course sketch for all 4 of them here. So absolute value, we know what the parent graph looks like. So we will sketch our graph here. Now the only thing that happens is that we moved up 3 on this graph. So got our axes in red, I'll make the graph itself in blue. So I go with a slope of 1 in that direction and a slope of 1 in that direction. Our domain is all real numbers, left to right, it goes on forever. My range, though, normally is 0 to infinity. Well, I moved up 3, so now I am 3 to infinity. Let's see, domain, range, zeros. There are no zeros to this function. It does not cross the y-axis. There's no discontinuities, and I sketched it. So we are covered there in number 1. Number 2 here, a little bit more of an interesting graph. The parent graph is a parabola. However, this graph was shifted to the right 4 and down 5. 1, 2, 3, 4. 1, 2, 3, 4, 5. So we have that as our vertex down there, which is important because that's going to tell us stuff about our domain and range. So right 4, down 5. Now this 2 is interesting here. Normally we have the point 1, 1 and 2, 4. Well, now we're going to have, instead of 1, 1, we're going to have 1, 2. But remember, we moved to the right 4 and down 5. So that point, which was 1, 2, that point, that was a little sloppy point there. The point which was 1, 2 moved to the right 4. So that makes it a 5. And down 5, which makes it a negative 3. So after the transformation, it becomes that point, 5, negative 3. Which means also that our other point, which was negative 1, 1, negative 1, 2, we'll do the same thing. I'm going to move to the right 4 and down 5. So I'm at 3, negative 3. And now we got a pretty good graph. This is, as some of you call, narrower than before. Whoops, that curved up a little more than I intended it to. There we go. Okay, and now we want to talk about our domain, which is all reals, left to right forever. Our range, which normally is 0 and above, in this case will be negative 5 and above. Domain, range, zeros, we got to find that. So we got to set this guy equal to 0 here. So let's look at this. We'll set it equal to 0. We have 0 equals 2 times x minus 4 squared. Minus 5, that is a lovely color of pink there. So 5 equals 2 times x minus 4 squared. Divide by 2, 5 halves equals x minus 4 squared. I'm running out a little bit of room here. Now I'll square root both sides, plus or minus the square root of 5 over 2 equals x minus 4. So, and following the little pattern here, little trail, x equals 4 plus or minus the square root of 5 halves. And of course, if you wanted to put that on a graph, you would want to convert that to decimal form. We have no need to put that in decimal form, though. We have our graph, and it's a sketch, so I don't need to be exact. But we do now know that that is the point 4 plus the square root of 5 halves. And that is the point 4 minus the square root of 5 halves. All right, and discontinuities, there are none. For number 3, this looks like a nice parent graph shifted to the right 1 unit. So normally we're coming down along the y-axis and along the x-axis. Well, now if I shift to the right 1, I'm going to come along the line y equals 1. Come along the line x equals 1. And this guy will come and cross the y-axis and run along x equals 1. So my domain, instead of being all reals except for 0, is now all reals except for 1. And my range, well, I did not move up or down at all, so my range is still all reals not equal to 0. So when we're talking about discontinuities, this thing is continuous everywhere except when x equals 1. So it's discontinuous at x equals 1. I cannot plug a 1 into this problem. Domain, range, discontinuity, sketch, and zeros. Well, you can look at the graph. There clearly are no zeros in this one. Let's go look at number 4 now. Here's our axes. Now this doesn't look like a parent graph, at least not yet. So let's check out down here. The numerator looks like something we want to try to factor. X plus 4, that's convenient. X minus 3, and I said that was convenient because the bottom has an x plus 4 in it as well. So I am now going to remove the x plus 4's, which means x equals negative 4, wait for it, is a whole. That's a type of discontinuity. X equals 0 is an asymptote because that was not removed. Okay, x equals 0 is still an issue. So at this point, my equation is x minus 3 over x. Well, that might look unfamiliar to you, but that really is a parent graph. Let me show you. We're going to slide over here now. X over x minus 3 over x. That's the same thing. I just simply rewrote this. Well, x over x is 1 minus 3 over x. So what happened here is I took my parent graph of my reciprocal function, which was 1 over x, 2 over x, 3 over x, whatever you want to call it. Normally this guy here in the first and third quadrants. Well, we are now flipping my entire function. So it's going to go over the x-axis. So it's going to be in the second and the fourth quadrants. But I'm going to add 1. So it's going to be up a little higher now. So we are going to flip it and move it up 1. Flip it and move it up 1. Okay, well notice x equals 0 is an asymptote. I still have the y-axis, that's x equals 0. It is not crossing that. Okay, and also recall negative 4 is a whole, so I need to go over here to negative 4. Put a hole in my graph. And then I want to find out what that y value is. Well, I simply plug in negative 4. Okay, and I'm going to plug it in up here actually. Negative 4 minus 3 is negative 7 over negative 4. So actually it's at positive 7/4 then. Okay, so x equals negative 4 is a whole, and that coordinate is really negative 4, comma 7/4. The domain, well, domain is everything except for negative 4 and 0. And my range is everything except I can't be 1 and I can't be 7/4 because that is a whole. And there are our parent graphs. And it appears as though I had a bunch of symbols disappear, so I'm going to show a little magic here. I'm going to go forward, and then I'm going to go backwards, and wait for it, voila, my symbols are back. Interesting technology we have here, but nonetheless, it allows me to do this, which I think is helpful. So let's look at these problems here, 5 through 12. They should go pretty quick. We're given a linear function, f of x, and a quadratic function, g of x. and we're asked to do some compositions with these guys. So f plus g, that's simply adding them together. So x, well, that's a little thicker than I wanted. So x plus 2, let's go right there. That's still thick. Oh well, we'll fix it later. F of x plus g of x. So x squared is all alone, so that's just an x squared. I have x plus x, that's a 2x, and I have 2 minus 2, that's 0. I'm done. I'm trying to get like a 1 or a 2 font in there, but it's not letting me. Okay, f of g. So I'm going to take my g function and put it into x in my f function. So f of g of x is equal to x squared plus x minus 2 plus 2. This plus 2 is the rest of my f function. And I just add them together and I get x squared plus x, and I'm done. F inverse of 3. So f inverse of 3, this is interesting because I don't have the inverse function. Okay? But we can do one of two things here. One of two things. I can find the inverse. F inverse of x. F inverse of x is going to be x minus 2. So if I want f inverse of 3, I'm going to get 3 minus 2, which equals 1. Okay, so that certainly is one option here. Your other option is f inverse of x. Well, if we switch x's and y's, I could simply take this x value and plug it in for y. Okay, so I could say 3 equals x plus 2. Equal sign didn't take there, which means x equals 1. Well, in the grand scheme, if we're switching x and y, I said this was y, which means my x is really my answer. All right, because if I'm doing f inverse of x equals y, and I put this in for y, then this is going to come out and be my result for x. Okay, so a little trickery there. It's just thinking about how x and y are switched. We're going to get an x equals response instead of a y equals response. The nice part is here, number 7, is that I actually did number 10 at the same time. So let's just jump right down here, f inverse of x. We switched our x and y, and we just simply solved and got x minus 2. Back up to 8 now. G of f of x. So now I'm going to take my f of x function and put in for each x in g. So I have x plus 2 squared, plus x plus 2 minus 2. And that's going to be x squared plus 4x plus 4 plus x. The 2's will cancel out here for a grand total of x squared plus 5x plus 4. I guess I can't scroll down because I need to know what my functions are. So f of g of negative 2, well, first I'll find g of negative 2. G of negative 2 is negative 2 squared plus negative 2 minus 2. Now, many of you forget about parentheses. Negative 2 squared is going to be a positive 4. Minus 2 minus 2, that comes out to a big fat 0. And f of g of 2. Well, I think I can remember what the rest of these are here. In fact, now I'm thinking about it, I do not believe I finished doing number 9. This thing's a little delayed here right now. So this is just g of negative 2. I still need to do f of that. So now I can go and say f of 0 will be 0 plus 2, which is 2. Now I'm done. And f of g of 2. So g of 2 will be 2 squared plus 2 minus 2, which is just 4. And then I need to do f of 4, which will be 4 plus 2, which is 6. And I'm going to scroll up